So, pretty much start. So, welcome to Dispatch. Bright and early Monday morning, packed in here for the exciting helium discussion. Let everyone grab their seats and we'll get started here. Blue sheets are circulating, I assume. People see them somewhere? Okay, good. And thank you, McManus, for taking notes. This is all under the note well. If you have not gone and read the appropriate BCPs, make sure you understand that anything you say in here is covered by them. So with that, it's pretty, we don't have a too packed agenda today. We'll start about some of the first things. So first, proposed dates for next time. Want to say anything about this?
Alrighty, okay, so the official MOF submission is earlier than any of our deadlines. So people, if you think you have something that's going to be fairly large, then you really need to start talking about it earlier. So September 28th, that's the deadline, just to let us know that you have a topic. And then ideally, October 5th, we want the cutoff for charter proposals. And by charter, we mean we want a clear problem statement. That's the important thing, right? And the objective of what you want to get done. And then we will announce the topics. We weren't so good this time. We just put the agenda out there, and then there's the usual draft submission deadline. Okay, and further details on the wiki.
And I will highlight on this too of just the BOF agenda. You know, if you get this out to us early first, we can help give advice about whether you might want to do it in dispatch or as a major BOF. So. Our mailing lists where we're doing our discussion, we'll remind everyone of that. And I think that we will now move on to the reason I'm sure everyone came, which is one of the best turnouts I've seen in dispatch in a long time. Thank you for all coming. The helium draft. So.
Good morning. Okay, thanks everybody for coming. I'm here to talk about a new, oh, it is working. Okay, then I'll have to figure out how to use it. Thanks for everybody for coming. This is a very early stage proposal. Unfortunately, due to the ordering of HTTP BIS and dispatch this meeting, things are in a little bit of a confusing order. So I'll be talking about this part of a larger idea here in dispatch, and then Lucas Pardue will be leading a presentation for a few minutes in HTTP BIS on a little bit of a broader perspective on what we're talking about, why we're talking about it. So I'll try to make this intelligible, even though we're a little bit out of order. So the goal here is UDP proxying, and the inspiration is the impending arrival of Quick. So HTTP has been self-proxying since HTTP 1.1. So that's the idea that you can, within the HTTP protocol, ask an HTTP server to forward a request for you to some destination. Now, that doesn't mean that the server has to actually do this, but at least it gives you a way to make the request. And participating servers can offer this functionality. When HTTPS was introduced, it was decided that this is an important function that HTTP serves, and so HTTP was extended to be able to maintain this functionality for HTTPS in the form of HTTP Connect. That lets you forward an HTTPS connection to a remote destination. But what about HTTP over Quick? Currently, if you set up a proxy, browsers have to actually disable all of their Quick functionality because there's no way to ask the proxy to forward a Quick stream to a destination, because Quick runs over UDP and there's no HTTP mechanism for forwarding UDP packets. So that is the inspiration here. Could we have UDP proxying in an HTTP system so that we maintain this self-proxying feature for Quick? And if we're going to be doing UDP proxying, then, well, it's useful for a bunch of other stuff too. It's useful for WebRTC, which currently uses Turn as a UDP forwarder. And also, it's UDP forwarding is a lot like VPNs. I'll get back to that in a second. Could we somehow cover some of those use cases too? Maybe we could even do something that's sort of halfway between a UDP proxy and a VPN. I'll talk about that in a bit. So the goal is to see if we could find a protocol that could cover all these different use cases. It's pretty simple and really works nicely in an HTTP-oriented system. So my claim to you is that a UDP proxy, so here's on the left here, this is basically my summary of the features offered to you by Turn. It gives you IP addresses, it gives you the contents of UDP, the UDP header, it gives you the contents of the UDP payload, it gives you a stable port mapping. This is just IP and NAT in a different formulation. But fundamentally, the information that we're talking about here is the information that's in an IP packet, and the function that the proxy is serving is very similar to the function that a NAT is serving in a network. Of course, the pieces have been taken apart and put together in a different order, but that's the data that we're really moving. So this is the Helium idea. The idea is maybe instead of building a UDP proxy in an explicit way, like Turn does, or like SOCKS 5 UDP does, maybe we could just take UDP and put it on top of IP and just use the IP header to move that information. And then maybe there's some kind of tiny wrapper that we need around IP if there's a little bit of information that doesn't quite fit into the IP header. And then all that can run over some sort of really good transport that gives us message-oriented semantics, security, congestion control, flow control, all that kind of good stuff. So we don't have to reinvent all of that. So the Helium describes two things. It describes first an abstract protocol, and then one sort of concrete possible instantiation of that protocol. So the abstract protocol actually barely even mentions UDP. It just describes something based on IP, but it's designed to be usable in UDP-only systems. There's this thing which is probably going to get renamed, currently called Helium Inner Protocol. It's just a very thin header. I'll show it on the next slide. It just has a tiny bit of information that you might want to add in addition to what's in an IP packet. And then transport is sort of not specified at that layer. And then there's a concrete instantiation. So in a concrete instantiation, you would take that header and encode it in some way. So I present an example of encoding it in CBOR. And then you can squish all of that into a WebSocket message, and now you have a full UDP proxy that has the security properties that we want, that can be multiplexed with HTTP and HTTP2, that can benefit from all of HTTP's identity and authorization systems, etc. So here's the entire, actually basically the entire Helium protocol in a nutshell. You can send a packet, you can receive a packet, and the one sort of interesting new thing really, well, I'll cover a few more of these details on the next slide, is that you can find out what happened to your packet. So that I think is, my view here is that basically this is what distinguishes a proxy from a VPN, essentially. VPNs forward your packets, and in the process, they have to transform them in a certain way. And generally, there's no way for you to find out exactly how that transformation occurred. If you can send a packet and also understand on the client what transformations the remote endpoint applied to your packet, then I claim that that essentially is a proxy server in the sense that we're talking about. So the goal here is to sort of split the difference, or to cover both cases. So the most interesting thing here, I'll talk in a little more detail about some of the fields here and why they're here. As I said, this is all very early stage work. So I don't expect that this is going to just, stay this way. But the most interesting mechanism here is the thing at the bottom, the last line, that the way you find out what happened to your packet is that the server echoes to you, if you request this information, the server will echo to you a packet prefix containing any modified portions of the outbound packet. So you send a packet, the server had to modify it in certain ways, and you get, if you want, an echo back of any aspects of the packet that were altered. So this is basically an ICMP style mechanism for building a proxy. So this is inspired by ICMP error responses, where if something strange happens in the network, you can try to find out what happened because ICMP will show you the beginning of your packet. So this allows us to avoid inventing a new protocol for ultimately transmitting a bunch of IP-related information and also potentially headers beyond the IP header. So if your proxy server needs to do things like rewrite UDP source ports, that's fine. You can totally do that. But then if the client requests this meta reply, then the proxy should echo back a prefix of the packet, including any parts that were modified, which extends out to the UDP header.
So of course, if you're behind a NAT, this is all wise.
Sure. If the proxy server itself is behind a NAT, then this only extends as far as the edge of the proxy server.
I mean, which can totally happen, right?
Yes.
Okay.
So the goal here is that there's no artificial limitations within the protocol. So for example, Turn explicitly is unable to represent a bunch of different things that you might want. Most notably, it's unable to represent ICMP, for example. So you can't do things like PathMTU discovery or traceroute using the standard ICMP mechanisms through a Turn server. But also, this allows us to proxy any kind of potentially crazy IP packet that you might want to form. Now, there's no guarantee here that it's going to work. In a sense, everything about this design is best effort. But crucially, if anything doesn't work, you can always find out, because you can get a reply from the proxy that says, no, actually, I'm not capable of doing whatever weird IP extension you asked for or weird IP option you proposed doing. So here's some fun stuff that you can do in this very simple design. You can build a UDP and ICMP proxy that doesn't require sock raw style access, right? You don't actually need to be able to form IP headers. This is inspired by the stun traceroute draft from the stun proposal. So that you can actually just use the error codes in the POSIX socket API to basically totally build a thing that will proxy both UDP and ICMP, which could be useful for more advanced clients. There's one of the reasons, so that there's a lot of people who've contributed ideas here. I'm not sure they all actually want to be credited, but one of the goals here is to build something that can help bridge networks, especially cell networks that have two parts to the path with very different path characteristics, a wireless leg and then a leg through the core of the internet. So the proxy adds timestamps. Actually, it can timestamp both incoming and outgoing packets. And a timing-aware client-side congestion controller could use that to separately observe latency past the proxy, between the proxy and the destination, so core congestion, and latency on the client-to-proxy link through whatever transport is being used. So that could allow more advanced congestion control systems that adapt, and the goal here is to be able to avoid some of the TCP over TCP serious misbehaviors that can easily occur when you have multiple layers of congestion control and packet loss recovery. Domain override is in here so that in a quick context, for example, you might want to contact a server by name it would be nice to avoid having to do a DNS lookup through the proxy, get an IP address, and then try again. So domain override says, I'm just going to ask the proxy to send this packet to a particular domain. And there's a little bit of language about how that has to work in order to make that actually function correctly. And then DNS server index is what if I want to do DNS queries to the proxy's preferred DNS resolver. So I want to use a local, nearby resolver for that network. But I don't just want to send address queries. I don't just want to connect to some IP address. I actually want to do TLSA lookups or ESNI lookups or whatever. This would allow that. So there's a bunch of other weird stuff. The last thing here is kind of funny. So if you want to bind an address, you can, there's no explicit command here because there's no even explicit knowledge of, for example, what UDP is in this protocol. But there's NAT, and so if you send a packet, then you're effectively binding an address, and you can use the meta reply to find out what address it was because your source port is rewritten. So that's about it for the Helium itself, and the other concept here is how would you use this over a WebSocket? So the idea here is that if a client is aware of a protocol like this and the server wants to implement it, then first the server, so on the left, this is a standard proxy connection to a server. So on the left, the server can say, by the way, here's a Helium proxy that I'm operating that you are also welcome to use. And on the right, this is the client actually connecting to that proxy. So reissuing their proxy authorization header to show that they're still authorized to use it, and indicating the protocol, and also just for fun, indicating compression, because WebSockets support compression, so you can actually zip your packets as, on the wire. Okay, so that's Helium, and welcome any thoughts on what to do with this idea, or even just with this problem.
I just have a sort of clarifying question about the sort of the NAT side of it to a certain degree, which is in some of the other stuff we've discussed, sort of filtering this binding address idea, right? What do you envision it will do? I mean, would different clients on the inside be able to use the same port number on the outbound side? Would traffic come? Would you have to send to an address before you could receive from that address from a filtering point of view? I'm just trying to get what sort of security properties you see the outside of this pseudo-NAT having.
Sure. My expectation, the current, this is a 0-0, but the current language in the draft says, I believe that the proxy must, so if the proxy is UDP aware, we should say, because it's actually possible to build a Helium proxy that doesn't even know what UDP is, that operates strictly at the IP layer. But if you build a Helium proxy that is UDP aware, the draft says that it should have address-dependent filtering semantics. So it should essentially be or actually it recommends full cone behavior, basically. But well, we can talk more about that.
Adam Roach, just as an individual, I'm trying to figure out the UDP protocols you see riding on top of this. Is this like for real time, or is this like almost exclusively for tunneling, quick, and other similar things?
I'm trying to, my goal is to see if we can find a very general purpose solution. So.
Okay. The concern that I have here is I look at, if you go back to the protocol stack slide, I see a UDP near the top and I see a TCP near the bottom, and that's a red flag for me, right?
Yes. So this is definitely a concern. One of the ideas in here is that eventually the goal here is to enable quick over HTTP over quick type proxying.
Okay.
So, just in the same way that you can do that you can currently do HTTPS over HTTPS proxying. So
Sure, but those are, I mean, those have the same basic protocols. It's not like head-of-line blocking is going to really trip you up there.
yes, I agree. So one of the things that I'm interested in here is that there's been some talk of WebSocket-like systems that run over Quick, and so so the WebSocket here is an initial option because it's something that's available today, and it's, I think, about as good as we can do over TCP.
Well, but TCP is kind of the problem, right? I mean, if you want a construct that is like accessible from inside browsers, I guess data channels kind of gets you there. But
so the part of the goal here is to run over HTTP, to be self-proxying in the way that HTTP is self-proxying.
Okay.
So right now you can run an HTTPS proxy over Quick. So you can forward a TCP stream through Quick by running HTTP Connect.
right.
And so essentially the goal here, I think, is to decouple these things, to run at a high enough semantic layer that that we run essentially over HTTP or over some HTTP related protocol, and then HTTP itself hopefully will run over Quick, and so we will at least have an option that has the right performance characteristics.
Okay, I guess the headline then is we probably need some really like clear language in here that caveats if you do this, things will probably go badly for you under a lot of circumstances.
Sure. So Lucas will be presenting this afternoon an alternative version of this, that instead of doing WebSockets, one of the things he has proposed is defining a new HTTP2 frame type, with the idea that new frame types have an easier path toward out-of-order behaviors on Quick.
Okay, thanks.
Harald Alveström, can you go back to your first slide? That one. I believe that the first bullet is the way I understand the words proxy and HTTP is false. As in the inclusion of the domain of the address of the server in the identity of the resource was a stupid design mistake of HTTP 0.9, and the host header was an attempt to get us out of that rat hole. We haven't gotten out of it, but I believe that substantially the first sentence there is false. So we actually have that syntax in active use because it allows us to do caching, but caches are not proxies. Second, I'm worried about running two congestion control mechanisms on top of each other. It's a stupid idea. It was a stupid idea in ATM. It was a stupid idea in this radio linked protocol that we keep on using. It was a stupid idea in many different contexts, and I think it will remain a stupid idea in the future. So either this works, this assumes that there is no congestion between the proxy and the client, or so that that link runs at full speed all the time, or it will get into interesting resource problems. Third problem I have here is that this concept of UDP, you're defining a service for putting packets on the internet and surrounding it with a lot of pointers towards things like DNS and address allocation and ICMP and so on. But you talk as if you provide UDP to the client. Now, about 10 years ago, we had 15 years ago, we had a protocol for telling your netbox to send packets on your behalf, RZIP. And it never took off. But if you want to have a way to tell a proxy to put UDP packets on the network on your behalf, I think you can do a lot cleaner than this. I mean, I find this whole thing, very complex and with very little architectural thinking behind it, and that makes me sad. Probably there's a use case in there that you find useful since you're standing here talking about this, but I don't understand. But I don't see an architecture I can understand inside it.
Okay, I didn't hear a question, so I guess I don't have to answer it.
Nicely done. Martin Thompson. That was a lot of negativity from Harold here. I think a lot of those concerns are ones that we need to address, though. I'm far more positive on this. I think that the general idea that you have, the goals that you're looking to address, are quite fine. The way that in which you're going about it gives me all kinds of bad feelings, and Harold managed to capture a lot of those fairly well. Maybe I disagree with him about the relative utility of having the full URI in a request, but that's just a minor point. I'm sort of wondering whether or not this is turn that you're looking for here.
Sure. So turn is interesting. It's possible. I think turn has its own problems, right? Turn inherits stun syntax and has a bunch of weirdness, like the XORing the addresses with some.
I'm talking
weird
architecturally.
thing.
I'm talking architecturally rather than the actual
Sure.
manifestation of the protocol. The protocol's got all sorts of warts on it, and some of them are fine, and some of them we don't like, and some of them won't really be necessary in this context,
Sure.
and a bunch of other questions like that. But fundamentally, there's a lot there that has been thought about, and you know, turn TCP is a thing, and it has all of the properties that Harold was complaining about, but it exists, and it's a necessary evil in some contexts, and so maybe that's something that we should be looking at instead. I definitely think that Lucas's design is closer to what we want in that respect. I think that the idea that you have quick to some point and then you want to initiate, say, quick again from that remote endpoint is an interesting one, and one that I think we should be examining a little bit more. But
Yeah, so I fully recognize that this design is very different from the kinds of proxy protocols that we normally talk about. And in particular, it has this very strange best effort only semantic, where at almost every step there's no clear guarantee about what you're going to get, and that sort of reflects a pessimistic view of connectivity on the internet, basically. An idea that, like, you have to build your protocols to assume there are middle boxes in the way, so we're just going to be one more middle box, and we're going to get your packets where they go if we can.
Yeah. I think there's a number of inherent assumptions in the design that you're presenting that aren't being well explained in that,
Sure.
in that role.
So in terms of turn, I'll just mention to you that turn has a number of interesting characteristics. One of them is that it proposes copying all of the IP flags, basically, things like ECN and DSCP, from the IP layer itself on the turn link to the external link, and vice versa, because it has no way internally of representing any of those flags. So if you essentially believe that those things don't matter, that IP doesn't have any attributes other than addresses, then and doesn't contain any protocols other than UDP, then turn is a very reasonable approach, and I would be fine with that. I think the question here, this is like the name says, this is a hybrid encapsulation for both IP and UDP. And I think the question is whether there's demand beyond the baseline of the simplest UDP.
Mike Bishop, Akamai, and also HTTP over Quick doc editor. So I definitely think being able to do an HTTP Quick equivalent to connect that would get you another HTTP Quick connection is something we're going to need assuming this quick thing takes off. Because currently that's how you get a TLS connection past a proxy, is you do a connect. And to say that people behind proxies cannot use quick to do encrypted connections out to the internet is kind of sad. Now, one thing I would point out on your architectural slide that you have the abstract layering and then one instantiation. This is really not the instantiation you want. It's just kind of the best instantiation you can have right now.
Yeah.
Because you want something with message semantics at least, so that's where you wind up in WebSockets. And fine, we can do WebSocket over H2. That draft is, I think, going to ISG soonish. We can port that reasonably simply into HTTP over quick. Fine. But the quick stream is still in order.
Yes.
And it's going to have head-of-line blocking. I think you at least have a way out from the congestion problem by having timestamps on it, so that maybe we can sidestep that congestion control inside congestion control. And you're essentially doing remote congestion controlling. But where you ultimately want is a feature that Quick doesn't have yet, which is to have a message semantic inside Quick, maybe associated with a stream, maybe not, but something Quick doesn't have, and you have a feature request for Quick here.
Yeah, and I guess I have a question mark in here about whether we're going to reuse the term WebSocket in some way to describe some way of exposing that up a layer, or whether we're going to have to go into HTTP quick every time we want those semantics.
I don't know whether it would be called WebSockets, but it certainly would not look like current WebSockets.
I just want to, we're going to cut the line after Ted, but thank you very much.
Justin Uberti, Google. Just speaking to the whole congestion control inside congestion control point. Now, philosophically, I understand the distaste here, but sort of speaking for someone who's running on a very large turn deployment, that in practice, we actually see these issues are not nearly as bad as you would think they would be. And that turn TCP actually works quite well, especially when you're using NAGL or have NAGL disabled on the actual TCP leg. And when in the cases when it actually turns out to be a problem, there are actually some clever solutions, like you can have multiple TCP connections for a single sort of remote endpoint, and then you can sort of round robin between them to deal with head-of-line blocking. So, like, we may find this kind of architecturally like inelegant, but there are some mechanisms that are well tested and can actually solve these problems.
Bernard Boba, Microsoft. Yeah, I actually agree with Justin. These things are very fixable with appropriate communication between the layers. But I actually was come up here to try to cancel out most of Harold's negativity by trying to say a lot of positive things. I think the problem you may have here is there are actually too many good problems you're trying to solve. And it may help to focus on a few. Certainly, I think the proxy one is definitely very needed. So you could do that one. But also, I will say that I'm not a lover of turn. I think it has a huge number of scalability problems, which could be potentially fixed by some of the ideas you have there. But that might be, I'm not saying you have to do all those things at once, but maybe if you focus on one problem and then focus on another problem, maybe you'll see commonality, and maybe you won't, and maybe those end up being two different things. But anyway, I like to encourage people when they come to IETF, instead of being abused, to come out with a positive attitude and know people think that they should come back. So.
Subodh Iyengar. I had one clarification question and then follow-up after that. So it seems like in the document, I sort of read through it, and it seems like you're assuming that, are you assuming that the end server, the target server, which is sitting behind the proxy, actually has no idea of the hybrid encapsulation protocol at all? Yes. Yeah, so there's like, so I think the difference between, for example, HTTP connects and, sorry.
No, not you.
Oh, too loud? Okay.
Cut the mic after Ted. And
so I think that there is a fundamental difference between the HTTP connect approach to proxying versus the NAT approach to proxying, which is that in the HTTP approach to proxying, the end server also cooperates in the encapsulation protocol as well. For example, so there's a stream ID associated with every data. Once you create a connect tunnel someplace, so actually, I'm going to go back on that a little bit. If you have I'm going to go back. I was actually wrong in that saying that. But what I'm going to say is that there's another way of doing this where the target server actually also cooperates in the encapsulation protocol, which is, for example, IP-IP GRE encapsulation, where, for example, you can enable interesting features like direct server return with those things versus actually rewriting IP addresses when you go traverses through the NAT implies like you have to correct the checksum when it goes through this NAT. So it involves a lot of performance problems related to that versus HTTP does not have these kind of performance problems. When we do these things like for L3 load balancers, we actually do IP-IP encapsulation instead of rewriting the source IP address. So the way I see it, at least, it seems like it's not as applicable to us, our use case, because we would do IP-IP encapsulation when we're doing it inside our data centers. But I'm curious about which use case this is applicable for. Is it more like a NAT, or is it more to replace the IP encapsulation that exists right now?
I guess I would say that this design more resembles a NAT for sure. At an ecosystem level, I guess I have difficulty imagining how we would get to a point where endpoint servers can be relied upon to be aware and participating. I guess my goal here is to be able to contact, at a minimum, any quick server in the world, for example, so that you can use this as a full forward proxy for all of your web browsing over quick.
Right. So in that case, you would have it's similar to an HTTP proxy. That's what you're trying to solve.
Ted Hardy, and indeed I also came up to talk about a scope thing and to possibly get you to think a little bit differently about what you're doing so that we can dispatch it, because this is what this working group is about, is figuring out where you go from here. Because what you just said was you wanted minimally to enable any quick server to talk to any other quick server, but then you went into a forward proxy that is HTTP specific. So you're actually talking about HTTP over quick, which is only one of the use cases of quick that we perceive will occur over time. It's not HTTP3, it's a transport onto which different application layer protocols will go. And so I think you kind of have a choice here, right? You can go and say, I want this to be very general, and I'm not going to inherit any of the characteristics of the particular application layer protocols, because what I'm giving you is a mechanism to encapsulate quick over HTTP. And from the point that it's quick over HTTP, it could be quick any application, right? And you have a generalization at that point that, you could do it with MIME types, you could do it with this, you could do it in a bunch of different ways, but you now know that you're using HTTP as a substrate for the transport quick, not the application over quick. Or you can say, hey, no, what I'm really caring about here is the HTTP side of this, so that I can use it in the same way that a connect proxy is used and get from an HTTP over quick, get to any HTTP over quick server using this facility. And I think we dispatch you in different ways depending on which one that is. And so I think it's really a question that maybe you want to talk to a little bit more, because in one case I'm going to say, hey, you actually should go into the queue at quick after the HTTP and its next application are done, so that we know we can use this over two different applications. And if you're really talking about it in HTTP only terms, I say we dispatch you to HTTP bits. And if in fact you care about being able to use this over something other than quick, then we dispatch you back over to transport to say you're a substrate to transport. So I think there are kind of three different potential scopes for this, and the dispatch answer is different depending on scope. So it would be really useful if you could describe which one you ideally want to meet.
Sure. Oh, great.
Well, you can answer Ted if you like.
So I think that's Lucas in the queue. Lucas has also thought a bunch about these different possible use cases and approaches to the problem, and has a draft on the topic. So maybe I'll defer to Lucas.
Lucas, you're.
Hello, can you hear me?
Yes, we can.
Oh, brilliant. Yeah, Ted raises some really great questions and points there. I'd say some of those aspects have been touched on in the draft I put together, which is using, it's framed in terms of HTTP initialization of network tunneling. So we use HTTP as a departure point, but don't necessarily use something like HTTP over QUIC as the substrate for the tunneling. It could, but it doesn't need to be. So many of these aspects have been collected into that ID in terms of design considerations, and we welcome further input. I'll be presenting that along with some more explanatory slides around some of the proxying models at tomorrow's HTTP Biz session. So if there's any further comments, I'd really welcome people to come there and continue the discussion.
Thanks. One other note I want to make is, so I'm not sure I entirely correctly understood your question, but my working assumption has been that QUIC itself, because of its encryption, makes it difficult or impossible to determine what use of QUIC is inside that packet. So my conclusion has been that anything that can move QUIC can move HTTP over QUIC or other things over QUIC.
So look, I was talking to Charles a second ago, and we were just trying to figure out how do we move forward from here. So here's our rough straw man for where we think are. Okay, there's quite a bit of interest in this. There's a lot of issues. There's questions about what the scope is, what the problem. Would we adapt existing protocols? Would we make a new protocol? How would this work with other things? Even questions, and whenever we end up in one of these sort of proxy tunnel type protocols, there's always questions about whether it's transport, whether it's art, how all that works. So it seems to us that we're at the point where we need some discussion on the list focused on what the big level architecture is, what use cases we're trying to hit, what the big direction is, and dig into this just a little bit more on the list and peel the next layer of the onion and have something a bit more specific before we can really dispatch it. And it seems that the dispatch list is as reasonable as any place to go do this right now. This is not obviously that it should be in transport or anything, and it's going to overlap. We're going to have to coordinate with people, and as it becomes clearer, we'll figure that out. But it doesn't quite seem ready to dispatch yet. Does this seem like a reasonable path forward? Anyone want to speak against this or suggest something else? Okay, ADs are okay with that? Good. Okay. So I know that sort of seems like unconclusive, like, yeah, keep discussing it, do more work, thank you for all the good work you've done, we'll most likely kill you in the morning. But I really think that that there's a lot of pain over our current things, and the quick stuff has sort of pushed it to the breaking point. We need to do something. So I think we need to make some progress on this and go from there. Good. Thank you very much. So that officially ends the dispatch session. Oh, no. It ends the dispatch session, and we're going to move to the art area meeting. If I can find the slides. Just, can you get me back up? Master slides.
You can skip this slide.
Okay, we have 5 area directors. No, we have 5 minutes for them. No, oh, we're all good. Okay. So, BOFs and interesting things this week.
You can do it too if you want to. I'm going to speak to the first one. So right after lunch today, we're going to have a BOF talking about how the IETF handles internationalization review and considerations in documents. Right now, we don't really have any formalized process around this, and it's been raised that it would be really beneficial to have some sort of additional supervision around how we handle these. The discussion's been going on in the mailing list so far is kind of driving towards setting up a directorate and probably putting together an RFC that provides some guidance. But not to prejudge the conversation we're going to have this afternoon. So if you're interested in this at all, or even if you're just free, I think having more input on this topic is useful. Thanks. Anyone else want to talk to RFC++? Is anyone in this room not aware of RFC++? So. And then, so you want to all talk about the Drew? Actually, I don't think I could provide much color on that.
Someone in the room want to speak to what's going to happen in the Drew BOF? Someone want to speak to what's going to happen in the RFC++ BOF?
Yeah, definitely the former. Martin Thompson, I've been following the Drew stuff. It's basically, there's been a bunch of things that have happened in DNS. Discovering a resolver is something that's been left off the table in a lot of those working groups. So DOE specifically did not address that question, and there's questions about all of the other DNS over TLS things. I'm going to talk about how they do the discovery in that context.
I didn't get any feedback from the chairs of these two working groups, but these two have formed since the last meeting. If they're of interest, they'll be meeting for the first time here. That's it.
Yeah.
Good morning, everybody. My name is Björn Hüneisen. I'm working with the PEP project, which aims to do opportunistic encryption, privacy by default. And we have submitted 5 drafts, which means there are 3 more than last time. Okay. Okay, you hear me now. Well, we have submitted 5 drafts altogether. There are 3 more than last time, and as I have 15 minutes, I can only go shortly into the content of these drafts. But,
Yep. Oh, there it goes. Oh, no, I just moved you.
okay, now it works. So I'm bringing again these 2 slides. For those of you that have been last time here, they are pretty much the same. Just to give a background for those who are new. So we aim to make the text communications like email, chat, private by default. We have good tools for privacy already, but not so many people use them. Actually, almost no one uses them for encryption. Most users are actually unable to use these encryption tools because it's too complicated, too cumbersome, takes too much time. And we intend to fix this challenge by doing that automatically. So in summary, we need not just good privacy, we need also easy privacy. Let's do it around. Well, in short, it is we have several building blocks that already exist. Actually, PEP architecture has several building blocks, and some of them are already mostly documented in RFCs, and we are intending to use these already existing building blocks from the RFCs. Some pieces are missing or incomplete, and these are the pieces we are focusing on, like filling the gaps that we can make pretty easy privacy and email encryption opportunistic by default. So this is one of the new slides compared to the last meeting. We've been trying to show you the message flow in a simplified way. So what happens first, whenever you start up your client and you have no key, then the client will automatically generate the key pair. And if you want, then you have a privacy status towards towards every peer you want to send messages to. In this example, we have a privacy status of B, of the channel to B, which means unencrypted, because we do not have any public key. Then you send the first message. This message cannot be encrypted because you don't have any key. But what we do, we add to this message your public key so that the other party has the public key. So what you see now happening is that as soon as the message is received at the B party, it will import this public key, and from that moment on, the channel to A is encrypted. This happens all automatically. B doesn't have to like take the key out, write some like PGP add and this kind of stuff. It's just done automatically in the client. And from that moment, B sends a message back, and all the messages are encrypted automatically and applied. This means now also the other side is an encrypted privacy status. So whenever A sends message to B, they are encrypted. To prevent man-in-the-middle attacks or like a higher degree of security, you also need to like establish the trust relationship between the two parties. So this is kind of something that cannot be fully optimized because trust you cannot do in a technical way totally. So what you're doing is, or the clients are doing, is take the two fingerprints of the keys, merge them together, make them to trust words, which I'm going to explain later. And then you compare these trust words over a phone line or just some alternative channel. And whenever you have successfully completed these trust words, you press a button on your email client, and from that moment on, the privacy status is trusted, which means that you can be sure that the message you're sending to them are going directly to them and cannot be read by an intermediary. So this is like in short what it is about, and now I'm going towards the drafts that we wrote. So this is one of the new drafts. It's basically defining the whole procedures for email. So basically define the missing pieces for email. And the motivation for this, as I mentioned, that the current systems do not encrypt all privacy sensitive information. Current systems still leave the subject unencrypted. For example, there are also other header fields that need to be more careful regarding to encryption. So the main use case is automatically encrypt emails in opportunistic encryption scenarios, as I just showed on the slide before. We define here some new message formats for privacy integrity, and also like how this is automatic key generation distribution works that I just explained you in the last slide. And here, just in brief, how one of these message formats works. Basically, this is encapsulation of the email, of the original email into an encrypted email. So we have the outer message that contains only what is really needed and removes all the privacy sensitive information. And then we have the inner message that contains everything, but this is encrypted. And in the inner message, we have the original headers and the content and the public key and all that. So the outer message looks like a forwarded mail with some encrypted content. Then, for this all to work, we have made a draft that defines the rating states. So the goal is that it's easy, understandable to the user. What is the privacy status to another user? It's like these colors I showed you in this flow diagram before. So that the user sees immediately, okay, emails to these users are encrypted, or emails to this user are even authenticated, or the user is authenticated to receive emails from you. The motivation is that to reveal the privacy status to the user. The main use cases is the presentation of the status of a user, but also the status of a message. Just for example, the first message is never encrypted, so this one is then like shown in a different color than all the following messages. There are some other cases where there can be differences between a communication status to the user and of a message of each message. So the method, we are defining here different privacy ratings, and we map these privacy ratings to a traffic light color semantics. So if it's authenticated and encrypted, it will be green, as I showed in this last slide. And if it's just encrypted, it will be yellow. And if there's something wrong, like the breach of a key or something, then it will be red. So that is about that. Then the handshake process I explained you, I'm going back again, which is this lower thing. So what they are doing before it gets from yellow to green is described in the PEP handshake draft. So we define an easy authentication process for communication partners. And the motivation is that for most users, the existing authentication methods are too cumbersome and not reused. So what actually happens is that, I explained it already before, we combine the fingerprints with an XOR function, and then we map that to the trust words. I explain you the trust words in the next slide. Then you compare these trust words over the phone line or some other alternative channel and update it. That's in rough, or in short, it's the handshake draft. And then the trust words draft, it's kind of an IANA registry definition draft, because we need trust words should be the same for all users or for all implementations, and that's what the IANA registry is a good means for. So we register the word lists in every language that they can be used by the clients. So this is the big picture. We have here like 4 areas. We have the core stuff that is in green. We have the trust words, handshake, authentication stuff that is here in fuchsia color. Another area is the applications like email or XMPP. And for email, we also intend to make a mapping for S-MIME. And then there's an area I haven't been talking about yet. It's the area of synchronization of keys. In case you have multiple devices, you have one on your mobile phone, one on your computer, one on your tablet. So all these private keys can be synced to devices so that you can actually also decrypt the message that has been encrypted with a private key, with a public key from the other device. And there are some more extensions to that. You can also sync the trust state. You can sync calendars and contacts. That could be like some further development. But the most important is to sync the private keys among the devices. We have running code for Outlook, Android, Thunderbird. It's released as Enigmail. And for iOS, it's a beta version. So that stuff is already running. The stuff we documented here is running. Then, while we come to IETF, we have, of course, a limited know-how what's going on in the world outside. We want to improve the compatibility to these existing implementations. We want to make the best MIME-based message formats, define missing URI schemes, as I mentioned before, the IANA registry, and also the private key synchronization. Then we discussed with the chairs here and that the dispatch working group is the best way to discuss this for the time being. So whenever you have questions or comments, use the dispatch list. If you want to get more like in touch with us, we have an IRC channel, we have web forums, and here are our email addresses you could send your questions to. This is my last slide, and I think we can take now questions.
My name is John Clenson. First of all, I want to commend you for trying to look at doing things this way rather than assuming that some sort of hop-to-hop mechanism is helpful. That said, and with the understanding that I found some of your slides a little hard to read, and I'm not sure I understand this proposal until after I get through reading things I haven't read before, like, for example, SMTP. I think a careful analysis of what happens and how stable this would be in an environment where messages are passed through third-party relays over whom the endpoints don't have as much control as they sometimes think they do, or through IMAP and POP servers who can mess with the messages and make certain that everything holds together under conditions of possibly slightly hostile actors in those environments.
I think my colleague is better to answer this question because he's more into it.
I'm Marcus from PEP Foundation. There's also a company trying to put that into business environments, PEP security, and they also talk with companies with exactly this issues that they want to probably do virus protection or to ensure that certain information doesn't leave the company. So for such cases, you can of course do key escrow inside the company, or when it comes to archiving, you can also there's also, that's in the general draft somehow mentioned, there's also a trusted server mode where you can save your messages unencrypted such that you can, read them without having keys. So there are different methods how you can deal with that. Of course, you need to trust at least your own infrastructure in the end, otherwise, it's for nothing, all these encryption things. So the project focuses basically on targeting mass surveillance. So if you need to somehow read messages of other people inside corporations, then you need solutions there, that's clear. But for, let's say, private users, you need to do that things on the end devices then to analyze after decryption what's going on.
I'd like to conduct an extremely quick poll. For everybody in the room who either now works for or has worked before for a very large company, would all of you who love your IT, unless you're part of the IT department, would all of you who love your IT department and trust them put your hands up?
I'm Keith Moore. I want to commend you for taking this approach and looking at it, and I appreciate what you're trying to do here. It appears that one of your assumptions is that the easiest thing to the most malleable piece, or the place that you can make the change to implement this, is in the user agents and not in, say, any infrastructure. I'm a bit dubious of that assumption, just because history seems to say that there's not a lot of incentive to improve user agents. I'd like to believe that we're not the case, but like I say, I'm somewhat doubtful. The other thing that I would take serious reservations with is the idea that it's okay to have devices exchange private keys with one another. And I want to really caution against the assumption that this acts on my behalf in any respect. Because what I have found personally is that this is a huge security hole. This is dangerous. This thing has entirely too much information about me. It is too easily compromised. And so I will never trust anything that expects this thing to exchange its private credentials with other devices. That is a non-starter.
Me neither. I wouldn't use email on a cell phone. But there is the use case where let's say a CEO or whatever wants to run around and read his email, so you can decide at least for certain mail addresses to do that, and for others not. I mean, that's I
understand why you want to do it. What I'm telling you is it's an extremely bad idea, and it will get serious scrutiny.
Yeah, but it's at least a use case which exists where people want to do that. But I agree that, I agree that the devices are fucked up, basically, all of them.
We're going to cut the line after the current people on the line, so that's good.
That's a technical term, right?
Oh, no. He's sort of invisible, but so he snuck in under the wire.
Well, he has to be less negative.
This is Barry Lieba. The history of adding features to email has shown that they work they succeed based on compatibility with what came before. And MIME was a perfect example of that, where when most clients didn't support MIME, messages that came, MIME messages that came through looked reasonably good, and people could understand what was going on. When we did PGP and SMIME, we set it up in a way that you can't read the encrypted message, but you can at least, you see who it's from and what the subject is, and you can go find out if you can't decrypt it, you know where to go to find out what's going on. With this kind of mechanism, the user experience for when the user has a client that doesn't support this is miserable. Right? The user just gets a blob in their email that says PEP, and they have no idea who it's from, what the subject is, how to find out how to fix this issue. So I'm concerned about that. And go ahead and respond to that while I think about the second piece.
If the user has made a public key, then he is getting these kind of messages. If he never made a public key, he's unlikely to get these kind of messages because they're only encrypted and this.
So go back to your beginning, your flow diagram there. And here's your thing where you, so if someone wants to send me an encrypted message and they have their key set up already, what happens here?
If there is already a key pair which we consider sufficiently long for RSA, it would be 2048, then we just use that. Otherwise, a new is generated if it's not sufficient. I mean, there is an author rating part which is not yet in the rating draft, where it's about rating crypto which we consider strong enough. And yeah, I mean, in cases where we would say it's not enough, we would generate just a new one and use that.
Brain check. I think I now understand what I missed at the beginning. So if A wants to send B an encrypted message, A sends it over there, but B is not prepared to generate a key and respond with an encrypted message back, so nothing happens. Is that correct?
I mean, you mean if you have a key for B, but he's not prepared to decrypt, or what? Or?
A wants to send an encrypted message to B.
You know, if there's no way to encrypt, it goes unencrypted.
So it's never going to connect. The handshake is never going to happen.
It just attaches the public key,
right.
But the handshake is optional anyhow.
Okay, that may mitigate my concern. The other part of the concern is what happens in failure conditions. I suggest that you take a really hard look at how to deal with that, because that's been a major problem with deployment of SMIME. So.
Yeah. Okay, that's one challenge.
Ron Gondwana. We talked a little bit yesterday, so you know a lot of my concerns about this, that email is something that is an archive for a long period of time, and that key management, it's easy to hand wave key management, but key management is a real issue. Assuming a working PKI doesn't scale. Assume devices are safe, doesn't scale. You've given a lot of ideas that there might be key escrow, there may be different people having different attitudes for how secure they believe their devices are, etc. It feels like there's a lot of complexity and a lot of work for the users involved still for a easy privacy, and a lot of decisions that people just don't make. As soon as you start giving lots of different options and lots of different ways at looking at things, people won't use them because it gets too complex. So I would be concerned about having a lot of different ways to interact with this, because the default will either be insecure or unusable if there are too many different ways.
Hi, Alvestran. Very commendable that you want to do this, and very nice that you'll paint my mailbox yellow if you succeed. But my big worry about this architecture is actually private key exchange, because the way you've set it up, you're assuming that each identity has one primary private key that all the messages are encrypted to. and that all the devices share access to this private key. So how do you handle the revocation of permission for a device?
There will be also draft on revocation. I mean, there should be an option to that you can say, okay, this device was hacked, so I want to revoke it, and that you can then issue new generation of a new private key, which then will be shared again.
But how can you then decrypt your old messages?
You keep your old secret keys. I mean, of course, if there is a breach of your device, your past messages at least. Yeah.
So if I lose this into the water and hand it to the repair shop, and the repair shop comes and say, oh, it was stolen, then I have no way to stop the decryption of the old messages from that device?
I mean, the idea, if you have at least two devices, the idea would be that you share both of the secret keys to both devices so that you have at least one left. I mean, if you have all of them lost, then you have an issue, of course.
No,
okay, so I didn't understand.
I'm saying that the key, the device has been compromised.
Yeah.
How do I revoke access from that device to my old messages?
You don't.
Okay.
You should be able to read them still. I mean,
So I want to revoke his access to my old messages.
Oh, yeah, that's not in that we don't have a concept here, but I think we discussed with you yesterday something which could probably.
So
yeah.
if we don't have a solution to this, then I'm quite worried.
So if you have ideas, we are open. Yeah. I mean, the main intention here for now is we want to encrypt more messages, because it's just like we have mass surveillance and nobody's doing. I mean, there's no easy solutions for let's say normal people, and yeah. Of course, if we can do it better, so that's why we are also here.
To me, this looks like it's an additional feature that may be also added, but it's not in our main focus.
ADs, any things you want to express? He sends stuff to area meetings. This happens to you.
Yeah, I think we're just chatting with my co-AD saying that this is not dispatch part of the meeting. We don't want to dispatch it. I think we need to, we'll talk within ISG about, and with interested parties about what to do about this work. Yes, keep discussing. Well, thank you for the presentation.
Thank you, guys. So,
hi, I'm Philhan Baker. So, web service discovery. Next slide, please. Oh, I get the remote. I've got the power now. It's not a phaser. Okay, so. So the basic requirement here is I have a bunch of web services, and they're web services that are actually exposed at some level to a user. And so when the user interacts with them, the name that they interact with can only be a domain name or something that looks like an email account identifier. It cannot be a web service endpoint. If you tell users to type in web service endpoints and use them as account identifiers, it doesn't work. As OpenID spent, 10 years discovering? So, and the other thing is that if a service is being implemented by more than one host, and those instances are slightly different encodings, whatever, different versions, you want to be able to go to the host that has the specific flavor of web service that you need. Now, the constraint here is that any of this has to work within the internet as it is, and not as we would like it to be. If somebody's trying to connect to a mail or a bookmarks or a calendar or any service like that, it has to work 100% of the time. If you have a mechanism that will work some of the time, but if they're behind a NAT, if they're behind a DNS that doesn't give you the full range of records, if they're behind a scripting interface that only allows you to resolve hosts and names, that doesn't work. So this has to work absolutely 100% of the time in the internet as it is deployed today. So you can suggest a better way, a more efficient way of it working for when they've got a capable internet, but you can't say, well, we have to wait 10 years for people to deploy NAPTA or URI records in DNS and support them at the name, the registrars. Okay, and you also want to be able to have a limited amount of service description. You don't need to describe every feature of your service there, but you do need to have the ability to say things that would allow a client to choose between two hosts that are offering slightly different flavors of the same service. And this is what then allows you to do a version upgrade. If you've got 100 hosts that are supporting the same web service, they're not all going to upgrade at the same time. And you might have a few around there that are supporting the old legacy protocol, and that number might shrink over time. So, okay. So, there is already a document out there that constrains about 95% of the solution space, and that's RFC 67363, which describes service discovery using SRV and TXT records. And basically, each time I come to do this, I end up writing a piece of document that says, okay, this is how you do it. You go to RFC 6763, and this is what that spec applied to this problem means as far as I'm concerned. And the thing is that each time I do it in a working group environment, it's kind of like, oh, well, do we want to use SRV records? Do we want to use text records? Oh, we could do it this way, we could do it that way. And that sounds great until you realize that this is a service discovery mechanism. And it'd be really good if all web services could at least, that wanted to do it in one particular way, had one particular way of doing it. Because at the end of the day, standards are about removing choices that don't actually matter. You could do this 5 or 6 different ways and still say you're following the SRV and 6763 approach. But when people come to implement them, they're going to have 5 different ways of doing it. And there's no real advantage of doing it a different way. So in 6763, you've got SRV records and you've got tech that do the basic service discovery. And then you've got the ability to graft on TXT records that describe the service. And yes, they're prefix records. And yes, some folk in the DNS world have not yet got fully on board with prefix records, but that's water on the bridge. It's just happened. Sorry. What you don't get from 6763 is a statement of, well, what happens if you're in a scripting language that doesn't support arbitrary retrieval of arbitrary DNS records? What do you do if you're behind a NAT or if you're behind some sort of firewall that is filtering out records that it doesn't know? And you turn out that, yes, 99% of the time, the internet behaves, but there's still enough times that it doesn't. So the proposed approach is basically to follow what's there and clean it up a bit and explain it in the context of, if your problem is discovery of a web service, this is how you apply that other approach. So you're using the SRV and TXT records as the preferred mechanism for discovery. And where there's a slight difference is that where we still use SRV records to obtain the set of hosts that might implement this service, we have the ability to use a TXT record to describe a service that is every host that supports that service. We've also can use the TXT record to specify the particular implementation for one particular host. And so if you've got different hosts that support different encodings, you might have a CBOR version of your web service, and a JSON version, an NSN1 server version, and they're not necessarily on the same host. This allows you to go to the endpoint that you want. And then there's a fallback if you've not got the ability to get those records. It falls back to service.domain and use the well-known service and the same prefix to complete the web service endpoint. And then as the very last chance, it will look at domain. So here's an example. So we've got alice@example.com, and we've got a bunch of records here that are describing various pieces. So we've got 2 hosts that are supporting the mathematical mesh protocol. And so you look at the top. So the first 2 are the SRV records that are basically mapping to 2 hosts. And then underneath that, we've got a CNAME record that says, okay, if you try to resolve mmm.example.com, here's a CNAME to go to host 3. And then if you look down here, we've got host 1 and host 2. Those are the A records that are needed by the SRV. Host 1 doesn't have... Now, there's a decoration here. There's a TXT record that says all the hosts support versions 1 through 2.0. And then here we have, at the bottom here, on host 2, we have a decoration that says, here's the endpoint to use for this particular host. And then at the bottom here, we've got the fallback records doing round robin, no SRV load balancing or whatever. It's going to be less efficient, but hopefully that's the 1% of the cases that would otherwise just crash. Okay, so what do we do with this? What I don't want to have to do is to write this type of thing again and again in different web service type working groups and do it slightly different each time. I would like to do it once so that then we can have one way of doing it and get some consistency, and people can use the same library to support different web services. So depending what we do with it depends upon what people are interested in doing. If people are really interested in this approach and want to define new tags for things beyond the path, the version, and encoding, things that would require actual discussion, then I think that we'd need to form a working group. But if people just want to do the very simple stuff that's specified in the draft, well, it is little more than an increment on an existing specification, and just takes that specification and says, here's how to do it for web services. So in that case, maybe an AD sponsored draft if the ADs are interested. So that's it. Comments?
Mark Nottingham. Jesus.
Yes. No, you're Mark Nottingham last time we checked.
Okay. Is that all right? Okay. No, there's still a hum. I'm kind of scared. No, not that kind of hum. So what you're describing here feels a lot like RFC's. Jesus.
No, just RFC's. Tell us after the number. What did you have for breakfast? Just keep going. It's really not ringing out here.
Okay. Okay, RFC 6415, host meta, which is the reason Aaron joined me to do the well-known registry originally. The big difference between what you're proposing, I think, in host meta is host meta uses link relation names as the keys into the services rather than service names. And so I think maybe one thing that would be interesting to do would be to dig into what properties do you want to get out of reusing service names rather than something else like link relations. because using SRV is not very web-like. Link relations are arguably much more web-like, and if you want to use this for web services, the question is what kind of properties do you want to get out of using those? SRV. We're having a session tomorrow about SRV and HTTP and how they don't terribly work very well. So that's I guess where I'd explore as to why you're taking this particular path there.
Okay, well, I'll have to get my mind around that, and let's take that offline.
Take a look at the host meta
yeah.
spec, because you might find it very interesting, or you might say, oh, this isn't going to work obviously because of X, and that would be interesting. Because it's not like host meta's taken off and taking the world by storm. So
yeah, I mean, the thing is, I mean, yeah, I've done web services. I wrote the first thing that became a web services standard, I think, XKMS. So I've been doing it a long time, and as I've been going on, I've been thinking, well, this has really got less and less to do with the web. And, I'm wondering if maybe all that folk were really ever trying to do was to get around firewalls. And so for a lot of them, I mean, yes, it's not looking terribly webby. I'm not sure whether that is a bug or a feature. In that, most of the time when I'm writing a web service, the first thing I do is to say no cache, because I disable all the stuff that's in HTTP, and then basically I've ended up with a TCP stream. So the only thing I'm getting out of HTTP now is the framing. And when you start to look at Quick, I start to think, well, maybe what we should do is simply just admit that web service is a different thing.
Maybe we should take it offline, because there's a whole industry around this discussion right now.
I know.
Yeah. But I mean, could you use WebSockets for what you want to do, or?
Well, not really, because
it's more of a stream than a
Yeah, I mean, the thing is that this is about how do I get to that webby world. This is about how do I do that initial bootstrap that tells me whether I'm going to go over HTTP over Quick, if I'm going to, what type of encoding, which type of version, all that stuff this is stuff that the DNS should be providing, because that's really what the DNS is about. What it isn't about is telling you things that you can find out after you've started the stream.
I guess at the risk of angering another section of the community, to me, the underlying question there is how much do we want to base what we're doing on the DNS architecturally? Like, do you want to continue to be extending DNS? Or is it something where we're like, okay, let's keep that in a box because it's got its own issues?
Well, I see this as specifying the boundary between web services and the DNS to the extent of, okay, once you've got the TXT and the SRV, you're not going to be extending the number of records that you're using again, because so this is kind of like, yes, we're going to use DNS, but no, that next new record that you invent, probably not.
I mean, personally, I couldn't imagine using this. This doesn't seem to have any properties that I need for the stuff that I do. I guess I'm just wondering if anybody else is, if this is there's a common need here or not.
Bron Gondwana, I had many of the same questions. If you go back a couple of slides to where you've got, your example, sorry there. I noticed you've got a version with a specification in, is that supposed to be machine readable or human readable?
Actually, I copied that out of another...
yeah, because my first question at the TXT records, particularly per host, if you have a set of different hosts providing the service, is some human looking through that list and trying to work out which one they want to?
That is machine readable. There is a spec out there that uses exactly that. And so I was simply copying the existing ABNF from that specification.
Yeah, because certainly if you're trying to select which of the hosts supports a particular version of the API or a particular, we had an example of Quick versus JSON or whatever. Generally, with this kind of service, what I would expect is that the endpoint would advertise what it supports in an accept header, and you would then know what you could use to communicate with it.
Right, but you only get the accept header after you've connected.
Yeah.
Which is after you've chosen the host and started your TCP session, which is a bit late.
Well, if you've got some initial bootstrap that it can then point you to the place that supports the new version.
And this is the initial bootstrap.
Yeah, the initial bootstrap. The other thing I noticed there is you have a path equals /service on one of the hosts.
Yeah.
When you're talking about restricting standards, restricting options, you've given an option there, and then you have the same IP address for host 3, which doesn't have that path equals service. It feels like if you only got part of this information, it would fail. You need to
that
get
was
all
for
or none.
illustration
Yeah.
of the capabilities, not
Yeah,
that.
but
I mean, in practice, unless you've got a web server that is doing things besides web services on that particular domain,
yeah,
it's never going to come up. I mean, like for me, I don't really care about the, well-known polluting the URI space, because the hosts that I use are either they're just in a different namespace anyway.
The problem with well-known polluting namespace is it has to be on the top-level domain. It's not on a particular host or a particular path. So, but yeah, the problem with having something like the ability to specify the path in this is that if you can specify that per host, as you can see, you got a bunch of extra complexity that will be rarely used and rarely correct.
Yeah. Again, this is one of the features that, it is used in existing services that use this type of discovery. So, and given that, and the only time that I would think I would ever use it would be if I wanted to have one host, I wanted to have one particular host do a particular version.
Yeah.
And just have that on a different URL because a different thing was behind it. That's the only case that I think I would ever use it.
Thank you. Yeah, I can see that.
Jonathan Max, can you flip forward a slide again? To your, no, that's not, okay, that's not the slide, back, I guess. This one, yeah, no, that was the proposed approach. So my concern about having both SRV and the fallback to .well well known is that these are now two things that administrators have to configure and maintain, and what happens when they're out of sync, and so on and so forth. And you've confirmed that you have to have the fallback all the time anyway. So why not just have that and have fewer things to maintain? I mean, yes, it's a bit more overhead to have to go to a TLS connection, but I think the simplicity for implementations and administrators is much better.
In terms of how we're actually going to set something up, I mean, the cases where you would, as far as I'm concerned, I have hosts that serve my web service.
Mm-hmm.
I have my website.
Mm-hmm.
I have hosts that do web services.
Okay.
And the two are completely separate and always will be. And so the fallback piece is probably always going to end up as being some sort of redirect anyway. So
that's fine. But I mean, my point is that it's it always has to be there, right? And it has to be correct and the same as the other information.
It always has to be there if you're going to support, if that particular service is going to support the fallback, yes.
And I mean, I guess maybe for any service for which you would expect there to need to be fallback, I'd say don't have it be fallback, have it be the only thing, just for.
Yeah, but then you can't use the ability to talk about different version numbers, different content types, and do that intelligent host selection, which people who have been doing the existing services that use SRV and TXT for selection are actually making use of.
I think you could still. It might be, again, a little more overhead.
So it is an option. Yeah, I mean, the way that I do it is that I have a configuration file that I use that describes the service, and then I compile out the DNS and web server configurations from that source. So I mean,
Yeah. I mean, with correct tooling, anything becomes easier. But if somebody's having to type these TXTs into DNS by hand and configure the .well known by hand, then
I don't think that anybody can configure DNS by hand and get it right. The fact that 99% is done by hand.
That's another argument for not doing DNS.
Okay.
So where do we go from here?
Does anybody object? I mean, if the ADs are interested and I write it up as a personal draft, is that acceptable to people? Is anybody burningly thinks that this is something that needs wider discussion?
Adam Roach, yes. So in particular, and I haven't had time to look through the rest of the details, but looking at just what's on the slides here, I have some concerns about the way it's using DNS names, and I think that would need to go in front of people with a lot more DNS knowledge than is present in apps.
Okay, yeah. But yes, so
it's sorry.
Okay, so DNS dear is probably a place to.
I think consultation with them before trying to move anything else forward is probably your next step. Yeah.
Right. Okay.
Thanks.
And Adam, before you disappear, continue discussion on dispatch list. Is that a reasonable place, or where would you like, or would you like to see it on art? Where would you like to see it?
So I mean, if people in the room have feedback in the draft, I think dispatch is probably like apps level feedback. Dispatch is probably a reasonable place to do that. I think in terms of driving it forward, I'd like to see the DNS community get involved before we try to do a whole lot of more churning on improving the document.
Yeah, my prior experience with CAA was that sometimes it takes an RFC and actual deployment before the DNS community tell you how you did it all wrong.
I'm hoping we can avoid that.
Yes, it would be nice to avoid it. Because, yeah, I know just how difficult CNAME is, having gone through that hassle. And one of the things would be that hopefully this draft would provide the web services world, if there's one way that has gone through that process, that means that you reduce the risk of 20 people cutting their own and falling into CNAME traps.
Yes, I think I'm sort of proxying concern here, but it's like when I look at this, it's like you've taken a large portion of the DNS space and I sort of started squatting on it. It's like you're importing the entire service registry as host names effectively, which seems problematic. So I think that probably needs a little bit more thinking behind it.
Yeah.
But again, it's more of a, we would need the DNS community to give us feedback on that. Then I'm not an expert on it, right?
Yeah, I mean, there's a potential for collision, but only if somebody has a service foo and they have foo.example.com /wellknown/WKS/foo, then you'll get a collision.
Well, no, it's more a matter of if I have a host that's already called foo.example.com and it's got some bespoke HTTP thing behind it, and then I want to deploy something called foo, I would need to have some way of wedging that endpoint onto that server. That might not be feasible. So that's the sort of thing that I
hear from the DNS guy behind you for a second. Good.
My name is Andrew Sullivan. I don't know if I'm a DNS guy, but I will point out that in DNSOP there is currently just finishing or something like that an Adderleaf document that is about this entire registry and how to cope with it and so on. So this is a long festering problem. I don't know that document gets it, makes it any better, but it documents how it works. And I think it's a known problem that is as solved as it's ever going to be anyway.
Adam Roach again. So yeah, thanks for bringing that up. That actually pertains pretty well to the underscore prefix stuff. I don't, and I'm talking to Andrew here. Unless I've missed something, that doesn't actually talk about using non-underscore labels on C names or A records or anything like that, right? Okay. So it was the latter thing that I was more concerned about here.
So this is the general problem, though, of the entire TXT record challenge. This is the long-standing problem, and the basic problem is that if you have one of those kinds of things and somebody else might come along and register another name in there, then you're hosed. And this has been the constant hosing that we had. We had this problem with SPF. We've had this problem with dozens of text records. We have this problem today with every mail service in the world who tells you put this TXT record with this key at the apex of your zone, and what happens is you've got like 500 TXT records at the apex of your zone, and it's an immediate DDoS problem. There is no way to solve this generally without some kind of registry. If you want my personal opinion, the DNS is like well overloaded at this point, but it's the way that people are going to do it because that's the database we got.
Yeah.
So we're at our open microphone thing. If anyone has a burning issue the whole room needs to hear about, now's your chance.
That's not how it works as far as I understand it. I mentioned it before. We're having a little side meeting on Tuesday about HTTP and SRV because some people keep on saying, why don't web browsers support SRV? It's so easy. And other people say you're insane. So we're going to get them together and have a nice chat and see if we can at least kick that ball down the road a little bit.
What time?
Tuesday, 6:30. So that's after the HTTP session, in the Square Dorchester room, I want to say.
No, that's. I think you said Bar Oblique on the mailing list. Oh, did you? Okay, so we're having it. All right, so we're having it in the IESG room then. All right, thanks.
Well, with that, thank you very much. Make sure the blue sheet gets back to us.
Sign it again.
Smoking behind the.
Behind the door. I said it to you. Yeah? I'll drop the blue sheets.
I don't think I've signed it yet, so.
Oh, I didn't either. I just put our names on that.
Oh, okay.
I assumed it was, you know.
I'll take it.
You want to sign?
We should.
What?
I don't know. Doesn't matter. I mean, they only use it for the counts. Yeah.
Yeah, I know.
You got it?
Yeah, what time is it?
I'll take those.
I credit two pull requests for.
All work.
Out of like Matt's pocket or something.
Okay, okay. Oh, okay. So he's just find out. Okay. Well, I know, I remember.